Have you ever stood in front of a giant wall of tires and wondered, how on earth are these things made? It seems simple, right? Just a black rubber donut. But the reality is a high-tech, mind-blowing process that's more complex than you could ever imagine. Today, we're going deep inside a state-of-the-art tire factory to uncover the incredible journey from raw materials to the rubber that keeps you safe on the road. Get ready, because what you're about to see will change the way you look at tires forever. It all starts with a secret recipe. Seriously, every tire manufacturer has its own proprietary blend, like a closely guarded family secret. The main ingredients are natural rubber, tapped from rubber trees, and synthetic rubber, which is a petroleum product. But that's just the beginning. Up to 30 different ingredients are added to the mix. We're talking about things like carbon black, which gives tires their signature black color and incredible strength, and silica, which helps improve grip, especially in wet conditions. There are also various oils, chemicals, and antioxidants that all play a critical role in the tire's performance, durability, and lifespan. These ingredients are brought into a massive machine called a Banbury mixer. Imagine a giant, industrial-strength dough mixer, but for rubber. The raw materials are dumped inside and subjected to intense heat and pressure. The mixer's powerful rotors churn and knead the ingredients together until they form a hot, sticky, black goo. This process, known as mastication, is crucial for ensuring all the components are perfectly blended. The consistency has to be just right. This hot rubber compound is then sent through a series of rollers, which flatten it into long, continuous sheets. It's like a massive pasta maker, but for rubber. These sheets are then cooled and cut, ready for the next stage of their transformation. Now, a tire isn't just one solid piece of rubber. It's actually built from several different layers, each with a specific job. Think of it like a high-tech sandwich. First, we have the inner liner. This is a special layer of synthetic rubber that's airtight, effectively replacing the old inner tubes. It's the part of the tire that holds the air in. Then, we have the body plies. These are layers of fabric, usually polyester or rayon, that are coated in rubber. They form the tire's skeleton, giving it strength and flexibility. The number of plies determines the tire's load-carrying capacity. Next come the beads. These are two super strong steel hoops that are wrapped in rubber. The beads are the unsung heroes of the tire. Their job is to create a tight, airtight seal against the wheel rim, ensuring the tire stays firmly locked in place, even during high-speed cornering or heavy braking. Without strong, perfectly formed beads, the tire would simply pop off the wheel. It's an incredibly important component that requires absolute precision during manufacturing. On top of the body plies, we add the steel belts. These are woven belts of high-strength steel cords, also coated in rubber. They are placed around the circumference of the tire, under the tread. The steel belts provide stability to the tread area, preventing it from deforming under pressure. They improve handling, reduce wear, and most importantly, they add puncture resistance, protecting the tire from road hazards like nails and sharp rocks. This is where a lot of the tire's toughness comes from. Finally, we get to the part of the tire we all see, the tread and the tread is the grooved outer layer that makes contact with the road. It's made from a different, tougher rubber compound, designed for grip and durability. The sidewall is the smooth part of the tire between the tread and the bead, and it contains all the information about the tire, like its size and load rating. These final layers are extruded and precisely cut, ready to be joined with all the other components. All these separate pieces, the inner liner, the plies, the beads, the belts, and the tread now come together at the tire building machine. This is where the magic really happens. A skilled operator, or sometimes a highly advanced robot, assembles the tire layer by layer on a rotating drum. It's a bit like building a layer cake. The drum expands and contracts to shape the components as they are applied. Everything must be perfectly aligned. Even a tiny misalignment could create an imbalance in the final tire, leading to vibrations and unsafe driving conditions. The result of this assembly is what's called a green tire. It looks like a tire, but it's soft, flimsy, and has no tread pattern. It's not ready for the road just yet. The green tire now heads to the curing press, and this is where it gets its final shape and strength. The green tire is placed inside a massive, heavy mold. This mold has the tread pattern and all the sidewall markings engraved on its inner surface. A flexible bladder is inserted inside the tire and inflated with hot steam or water, pushing the soft rubber outwards with immense pressure against the hot mold. This process is called vulcanization. The combination of heat and pressure triggers a chemical reaction that cross-links the rubber molecules, transforming the soft, pliable green tire into the strong, elastic, and durable product we know. This curing process can take anywhere from 10 to 20 minutes, depending on the tire size. Once the curing is complete, the press opens and the finished tire is ejected. It's still very hot and has a distinct smell of cooked rubber. You can often see tiny rubber hairs, called vent spews, on a new tire. These are from small vents in the mold that allow trapped air to escape during the curing process. They don't affect performance and usually wear off after a few miles of driving. But the journey isn't over yet. Every single tire that comes off the line goes through a rigorous inspection process. Quality control is paramount. First, a trained inspector visually checks each tire for any cosmetic blemishes or manufacturing defects. They run their hands over every inch of the surface, feeling for imperfections. Then, the tire is sent to a series of machines that check for uniformity, balance, and structural integrity. One machine spins the tire at high speed to check for any wobbles or imbalances. Another uses X-rays or sensors to look inside the tire, ensuring all the internal components like the steel belts and plies are perfectly positioned. Any tire that fails even the slightest aspect of these tests is immediately rejected. There is zero tolerance for error when it comes to safety. So what happens to the tires that don't make the cut, or the leftover rubber dust and trimmings from the manufacturing process? This is where modern factories really shine. Sustainability is a huge focus. Much of the uncured rubber waste is simply fed back into the beginning of the process and reused. It's a closed-loop system that minimizes waste. For cured rubber and tires that are rejected, they aren't just thrown away. They are sent to recycling facilities. There, they can be shredded and used in a variety of applications, such as playground surfaces, athletic tracks, or as a component in asphalt for road construction. This commitment to recycling ensures that the environmental footprint of tire manufacturing is kept as low as possible. From a secret blend of over 30 ingredients to a complex assembly of multiple layers and a final transformation under intense heat and pressure, the process of making a single car tire is an incredible feat of engineering and chemistry. The next time you get in your car, take a moment to appreciate the 4 black donuts that connect you to the road. They are so much more than just rubber. They are a marvel of modern manufacturing, designed and built with one primary goal in mind: keeping you and your loved ones safe on every journey. Thanks for joining us on this look inside the tire factory. If you found this as fascinating as we did, make sure to hit that like button and subscribe for more deep dives into how the world around us is made. Let us know in the comments what you'd like us to explore next. See you in the next video.